Hi, everybody. Audio on? Can you hear me okay? Okay. So, Scott Grimes, I'm a senior director with Marriott. And today, here's what I'm going to talk about with you today. Here's what I hope you get out of this session. When you hear Emil talk, a lot of times he talks about graphs are everywhere. At Marriott, what we did is we found a use case that is not part of the 6 common use cases that Neo4j markets itself on the web, and had some insight and realization that graphs truly are everywhere. We were able to bring that into Marriott. I'm going to talk a little bit about how we did that. And one of the key takeaways is to recognize that if you have data, that there's relationships between that data. You can look to solve problems that aren't necessarily one of the 6 common use cases or some of the common things that you see in terms of a marketing presence on the web. I've been with Marriott since 2013 this time. I'm what we call a boomerang. I was actually at Marriott from 2006 to 2008. When I was there in my previous role, I was the director of application architecture for the Marriott.com website. And through my career, I've managed a wide variety of teams on a lot of different technologies, primarily in a high-performance environment. For example, 2 of the top 4 banks, online banking sites, I led re-platforming efforts of the online bankings after there was a lot of bank consolidation activity. If you remember in the late 90s, early 2000s, there was a lot of financial services bank consolidation that were re-platforming their online banking systems. And on a personal note, getting a lot of enjoyment this year, coached my son's youth football team, and I also love to play chess. It's a very good game that I enjoy. So Marriott, it's a household name, largest hospitality company in the world. We recently completed the acquisition of Starwood. Currently, we have about 4,500 properties. Once we finish the acquisition with Starwood, which legal day closes 2 weeks ago, and all of the hotels that we have in the booking pipeline right now, we'll be at 6,500 to 7,000 hotels by the end of 2018. In terms of total rooms, we have 700,000 rooms currently. On that time frame, by the end of 2018, we're projecting that we'll be close to 1.5 million rooms. So, happy to be here today to talk about the experience we had with Marriott in a Hyatt. And I'm not quite sure with the cipher query that the Neo team ran to say that this would be a good idea, but we're going to go ahead and make that work.
Sorry.
In terms of internet sales, so just real quick poll from the audience. Who are some of the competitors of Marriott? Who do you think of as competitors with Marriott? Hyatt? I would think so. Airbnb, Expedia, Hilton. But one of the key things that we started to realize at Marriott is our competition isn't just the hotel companies, the traditional hospitality companies that you think about. Our competition is a lot of the technology companies like Airbnb, Expedia, Booking, those websites. And they don't have hotels, they have data. They use data as a platform to be able to connect a product to a guest. And they use it to do it from an IT perspective. This culture in Marriott has really taken hold in the past couple of years that you'll hear our CEO, Arnie Sorensen, talk about. Marriott is transforming to become an IT company. We're recognizing that our competition isn't just the hospitality companies that you think of traditionally, it's the IT-based companies that have data that we're in competition against. There's Airbnb, Expedia, the ones that we know about now, Google, Amazon, Apple are talking about getting into this space as well. So Marriott is looking to reposition its IT and think of the offerings that it brings to market in terms of an IT company and a data company, not just a architecture construction rooms. From a digital sales to support that, we were $15 billion in 2015 in terms of sales through our .com and our mobile channels. On the IDC retailer ranks, that would actually put us into the 7th largest website on the internet. After we complete the acquisition with Starwood, using the 2015 numbers, that would push us up to number 5 when we pull in new sales that we would get through the Starwood properties as well. 1.5 million rooms at the end of 2018 for Airbnb, for example. They have 2.5 million listings, and those aren't necessarily true rooms, but they have 2.5 million listings. Marriott's going to be managing 1.5 million. That's a substantial thing. We also have to go through the complexity of how are we going to price, how are we going to manage that inventory, something that other companies, the data companies, don't necessarily necessarily have to do. They take the products that we create and try to make a connection from that. 1.5 million rooms at the 2018 numbers. 1.5 million listings. Marriott's going to be managing 1.5 million. That's a substantial thing. We also have to go through the complexity of how are we going to price, how are we going to manage that inventory, something that other companies, the data companies, don't necessarily have to do. They take the products that we create and try to make a connection from that. Within revenue management, our goal is to offer the right room at the right price to the right customer. So that involves customer segmentation. We manage our special corporate relationships with like IBM or Accenture or some of the other companies that we would have those relationships with. And then specifically within pricing, one of the main platforms that I support have to go through the process of how do we provide pricing recommendations, take the pricing recommendations and provide a system for 4,500 properties globally to be able to maintain a pricing strategy. We have a 365-day booking horizon. So when you go to .com, it looks very simple when it comes back and says, in this city, at this property, on these days, this is the rate. It's just a number, that's what you see. The amount of complexity that goes beyond that in the business domain on determining what that number is, there's booking curves, forecasts, anticipated forecasts, supply. All that information is taken into consideration with the competitor shops to come back with those recommendations. I can truly say with a wide variety of industries and experience that I've had, pricing is probably the most complicated business domain I've ever seen or worked in. So I want to take a basic building block and give a little bit of the business context of how we went through a journey to get to the point where we established a relationship with Neo4j. The basic building block is a rate program. What you actually buy from Marriott when you go through a channel, you don't actually buy a room. You actually buy a rate. That rate has associated with it terms and conditions, such as if you go to the .com site, if you can actually see this on our listing, we'll say standard rate, and then there's a listing of rooms that rate applies to. Then we'll say advanced purchase. If you agree to buy a certain number of days in advance and agree to a cancellation policy that would forfeit a first night or last night of your deposit, that will give you a discount. And then that applies to different rooms. So really what you buy from Marriott is a rate, and the basic data structure that we use is a rate program. That rate program has within it seasons or date ranges that says for this segment of dates, this is what the price is with these terms and conditions. When it changes, that starts a new season, and that goes a year in advance. The reason why I wanted to just go through what a rate program is in the season concept, because that will show how the complexity of the pricing strategies that Marriott's been able to do in the past couple of years has increased significantly. Prior to the implementation of our pricing application, HPP or high performance pricing, it was a manual-based system, mainframe, green screen-based system. It's a mainframe system that's a derivative from the airline industry. And the process to be able to maintain pricing was completely manual. There was one level of mirroring that you could have. Rates were changed relatively infrequently because of the complexity of maintaining that. We were also limiting ourselves in terms of the complexity or the breadth or offering of the products that we could provide. Generally, before 2012, prices would change around monthly. I talked about a rate program goes 365 days in advance. Because of the complexity, we generally change our prices monthly just due to the manual nature of being able to maintain that. In the second quarter of 2012, we deployed HPP. Brought about a new level of complexity. With the rate program now, we saw properties start to do pricing weekday, weekend. So instead of 12 seasons on a rate program, we grew to about 104 seasons on a rate program, where you could have a weekday, weekend each week for 52 weeks. We additionally offered the capability for 4 levels of mirroring, of nesting of the data. So for example, with Marriott, you could have your retail rate, and then you could have a package like a stay for breakfast. If you stayed at our property on a weekend, which is more for leisure travel, there's an offering that you can have breakfast included with your stay. From there, you could do an advanced purchase, stay for breakfast, so that you start to get deeper levels of mirroring and referencing that we weren't able to do before. One of the key concepts to understand is when the rate is returned today, that rate is actually pre-calculated. So what I'm going to talk about today is the process of how we go from our HPP application for how we manage seasons and rules and pre-calculate that information to make it available so that when you see it through a channel, all it is, the metaphor we use is we put the rate on the shelf, and when you get a price back today, it is pre-calculated and is being returned. But we had to solve a complex problem of how do you take this nesting and levels of data and make it available through that pre-calculation process. The initial implementation used a commercial off-the-shelf rules engine, and it was using a radio algorithm to be able to compute that, and we wrote a custom rules editor to be able to maintain the seasonality. it's robust for maintaining an overall pricing strategy. However, the publishing time was taking minutes, sometimes hours, for changes to be updated because of the complexity of the processing and also some inefficient things in the architecture that was causing this to take a very long time. If you were maintaining a strategy and you wanted to change your pricing for a year out, it was a very good system or tool to be able to do that. However, if you wanted to go in and do a quick change, for example, an airport closure, due to weather or something like that, a property wanted to be able to change their rate for that day instantaneously. Through the mainframe green screen system, they could do that. However, we still were taking minutes or hours to be able to process that, and there was impacts associated with that. From the first quarter 2014 through 2015, fourth quarter 2015, so this is a 2-year period of time, we deployed some innovative capabilities that we were able to hook our pricing recommendations that were provided, and through a one-click user experience, have that go all the way through the publishing process to end up on the system for sale. It was a swivel chair concept. So you had to go into, before that it was a swivel chair, that the recommendations, you had to look at your recommendations and then go into the system to maintain your pricing strategy. We implemented a capability to take that swivel chair out of the picture. We also developed a feature that we call auto bridge or auto publish, that a user could sign up and let their price recommendations flow through without even having to manually review them if they had trust or confidence in the system on what the rates were being recommended. We had to say no to deploying that capability as an IT organization. The system could not handle the volume of that many publishes in that quick of a period of time. We also started to see the emergence of more sophisticated pricing strategies, going from weekday, weekend to 7-day-a-week pricing strategies. So now the number of seasons or date ranges that we had to process or compute was growing from 104 over the course of a year, over 300, 350 for a year. We saw that we started getting to an average of the average rate program would have 200 seasons within it because properties were implementing these capabilities. At the end of fourth quarter 2015, we were processing 650,000 rate program updates per day from the properties that we have. That represented a 24-month growth of 110% from the fourth quarter of 2013. The complexity also increased because we went from an average of 70, theoretical was 104, but they were averaging around 70. We also saw about a 300% increase in the complexity. We really deployed a system out into the wild that our properties were innovating new pricing strategies and getting more sophisticated. They were increasing the complexity and wanting to increase the demand and the volume of how frequently they change their prices. However, we didn't have a back-end system to be able to support that. So that's the number of seasons increase, the growth. A real concrete, tangible example. January 2014, the Super Bowl was in New York City. Leading up to the Super Bowl, there was snow in the forecast. There was discussions from the NFL that they were talking about if it does snow, we may move the Super Bowl to Monday. This is in New York City, where Marriott has the most number of hotels within a metropolitan area. There's about 82 properties in the New York market. And what was happening is the hotels were shopping each other and trying to respond. Do I increase my rate on Monday? Is that the day of the Super Bowl? And decrease it on Sunday? What do I do with Sunday and Monday, the Saturday before? Just what is the pricing I should do for this? The properties were wanting to change their prices almost hourly on this time. There was about a 5-day period of time where we had backups and we could not process the pricing updates for not just New York, but globally, because the New York properties were publishing so much. We had 5 to 6 hour backups for about 5 or 6 days straight. Tremendous amount of frustration with the system. It simply wasn't working, and there was a business case to be had. So why did we have those challenges? One is publishing happens in bursts. I'm talking about the number of rate programs being updated at 650,000. I'm talking about the number of seasons increasing to 200. You multiply those together, and you're coming out to hundreds of millions of pricing updates per day. The fundamental issue that we had is we had a highly normalized data model that had 10 levels of data that needed to be traversed. With that data, we had 2 options what we could have done for the initial implementation. We could have tried to do SQL joins across 10 tables. We all know that that wouldn't be performant, so we actually went with option 2 as we built the application to be aware of what the data model was to be able to traverse that. However, as the complexity increased because of the number of seasons, we were seeing individual rate programs could take over 30,000 SQL calls to the database just to be able to process. Even if you have 1 or 2 millisecond response times from an RDBMS to be able to process that, you're coming out to 30 seconds plus to process a rate program. When a property does their publishing,
One of the key concepts we have is we have a few reference anchor points, and then everything is indexed off of that. So the advanced purchase product that we have that I talked about would be a certain percentage or dollar off the standard rate. A concierge access could be set to be a certain fixed amount above the standard rate. So everything was tied or nested or mirrored off of this. We had some properties that published when they would go through this process, they could update 1,600 rate programs instantaneously with one click of a button. If you start taking 30 seconds to do an individual rate program, you're starting to talk about minutes to be able to go through. Our average publishing time was over 4 minutes to be able to process, and for many properties with more complex strategies, they would never be below 8 to 10 minutes that they could try to implement a change, and it would take a very long time to be able to process. So we recognized that a rewrite was going to be necessary. We could not stay with a normalized model. When HBP was originally deployed in 2012, it was under the previous leadership at Marriott that was still thinking of more as a traditional hotel company. If you recall, I talked about how we're focusing on becoming more of a data company. We stayed with tried and true products. Marriott was very conservative. Our general posture was we would not implement a new technology or do an upgrade until the upgrade was generally available in the market for 6 months. That's the time that Marriott would start to consider doing an upgrade. Very risk-averse organization. We had a change in IT leadership that started to say we need to become a data company. So we started embracing more modern technologies, actively embracing open source solutions. So the timing was right. We had a change in leadership, and we had a fundamental business problem that we needed to solve or start to think differently. But the challenge or the trick was, what do we do? How do we solve this problem? We knew we had it, but didn't quite know how we were going to approach it. I gave you some stats through the end of 2015. We actually started this project in relationship with NEO in the second quarter of 2014. We were able to go through and do some performance tuning and optimization, but it wasn't going to be able to handle the explosive growth that we were continuing to observe. We recognized error. One of the things that I recognized was I was unaware of graph databases. I didn't know they existed at this time. But I started looking to social media for an inspiration. I looked at Twitter, I looked at Instagram, Facebook. These are companies that are achieving incredible performance at massive scale with data that is related to each other. Hadn't heard of Neo4j at that point. Really started to think about, you know what, our rate programs, the way that we have our mirroring, they're almost like Twitter followers. That there's an update or a change being made, I need to be notified as a follower of that parent. How can I get that notification? So I started doing some research into how does social media solve this scale and performance problem of data that's related. Through that process, came across a web page. It wasn't from Neo. It was actually just an independent blog that they had written a Twitter application that implemented Neo. From that point, I realized what I really had was I had 4,500 independent graphs, and that the data was related. And wanted to go through and see if that was going to be a viable solution for us. Started to research. I went through a process to be able to collect data. I had a family vacation coming up, and I was going to get some time away from the daily grind of being at the office every day. So I gathered a lot of materials, the graph databases book that's available for free from the internet, teed up a lot of stuff to be able to read on the plane ride out and to think about and to be able to how we're going to solve this problem. An urban legend grew when I came back with this idea of what we were going to do, that I actually got inspired while on a trail in the Grand Canyon. But that wasn't necessarily the case. Had the idea, took the materials with me, but it was a time away to really start to think about how do we innovate a new solution for Marriott that's going to be something transformative and different. So I came back from that vacation. I sat down with my team, and I challenged them to build a prototype in 8 weeks to demonstrate the feasibility. We established a relationship with some of the Neo team and made them aware of what we were looking at and doing some investigation. They provided some pre-sale support for us to be able to guide us on this prototype. And during the course of the prototype, we made a couple of the key decisions. One of the key ones is we actually found that we would need to implement with an embedded mode of Neo versus the server mode. Additionally, we wrote directly to the APIs, accessing the database directly, instead of being abstracted through Cypher. And for some other reasons, we stayed away from unmanaged extensions at that point. Although the prototype wasn't functionally complete, we were able to build a projection that we could process our most complex property, that one that did 1,600 rate program publishes that he would never finish in less than 8 minutes. We showed that he would be able to process in about 34 seconds through this model. Project commenced in 2014. Big thumbs up to be able to go forward with the project. We were able to put together an estimate of what we thought the cost would be, the licensing cost, go forward. So we went forward. with the project. So what does our deployment look like today? We started to roll out in the first quarter of 2016, so the first quarter of this year, and it took about 5 months to be able to deploy this for globally for the 4,500 properties. Interestingly, up until this point, our rules engine solution was the bottleneck in constraining what the performance was. That when we did a publish, we had to send this data and process this data as quickly as possible and send to our system in a pre-computed fashion. When we took the bottleneck out and were able to process much faster, we actually exposed constraints and bottlenecks in other systems as part of the architecture. Primarily on our mainframe system, we did go through the performance testing, but however, it's very difficult to simulate production workloads of a mainframe system in a lower environment. We actually started to expose some of those challenges and constraints and other bottlenecks in other areas. It was very satisfying to be in a call talking about performance of HPP, where I had to take it seriously and say, yeah, this is really a problem. We have to work on how do we get this through and not cause impacts to the overall system. But while on that conference call or talking to folks, not high-fiving people that we were no longer the bottleneck, because we had been the bottleneck for so many years at that point. We were actually exposing slowdowns in other areas of the system, something that had never been done before. To minimize the impact, we implemented Neo4j. We think of it as really it's an embedded mode, and we really think of it as a cache. So we still have our RDBMS that we would consider the system of record of what is truly the rules in this data that the users maintain. With it implemented in this way from a development team, we were able to much more control things that we did with Neo, and we didn't necessarily have to reach out to operations in terms of what is the backup procedures, failover procedures. We were able to control that more at an application level in terms of being able to innovate within a development team rather than have it become a larger effort of how does development coordinate with operations to be able to do that. That's the scenario that we approached. From a development standpoint, it also allowed us to minimize the changes to our rules editor that we had, so that when a user is maintaining their pricing seasons or their pricing functionality, we were able to avoid changes to that process, and we were able to focus on that back-end publishing process. When you hit one button to say publish my rates, that can lead to an explosion or a huge burst of activity that needs to be processed. One of the things that we had to develop ourselves. So our graph is really 4,500 independent graphs. It is not one large graph. The pricing strategies is unique per property. So that presented an interesting question of how do we size and scale the solution. One of the things that we really wanted to do in order to maintain performance and make this as fast as possible was to have all of the graph data into memory. When balancing the size of the heap and the other considerations, we landed that we would probably need to have 3 different clusters to support our properties. So we had 3 node clusters in a master-slave configuration, and we deploy them, but that meant we had to figure out how do we partition or shard across those clusters, because a property's data would be in only one cluster. We had to make sure we had the component to be able to route it. Had conversations with many on the Neo team about our use case is really primed for sharding. It's a complex problem. I can appreciate that. So we did go ahead and we wrote our own sharding component to be able to partition across those. We do have some of the operational capabilities that we can take a property and move from one cluster to another cluster if we wanted to, and how do we pause their publishing. So it's a fairly robust solution, but I can appreciate that what we've done is not genericized or abstract to be immediately part of a product. It's really part of the Marriott solution for how do we implement this. That's one of the reasons why, even though we started this project in the 3rd quarter of 2014, it took about a year. Our team size was 3 developers to be able to go through and rewrite this process to be able to go through. We're currently deployed with version 2.29 of Neo, and we're in process of upgrading that to 2.37. Some of the key things that we're looking to really get out of that is the delete capabilities between the versions. In the 2.2 line of delete, when you delete information from the database, it actually leaves that data in the database and takes up space. 2.3 provides some capability that you can actually have that cleaned out to be able to manage the database size. One of the things that we found is over time our database has grown in size from where some of our initial projections were. As part of this upgrade process, we're going to go through a compaction process to bring the database size back down, because there's a lot of data that's been deleted, to be able to maintain that size of the database and free up more room in the heap and require less memory to be able to operate. Additionally, with 2.3, removing the object cache as being elements within the heap, we're anticipating seeing some significant benefits from being able to do that, to be more memory friendly, to support for that. So we talked about what the business problem we had, what was the complexity that we've had a tremendous amount of growth of rate programs being published a day, year over year, near 100% growth of rate programs publishing, as well as the complexity from the number of seasons as we've gone from monthly seasons to now day-of-week seasonality. So what are the benefits that we're seeing from this today? One, we were able to implement that auto bridge feature that I talked about before that we said, no, we're not going to be able to do that. So we've implemented a capability that properties can now have their pricing recommendations that are produced on a daily basis. We produce pricing recommendations for the retail rate for all 4,500 properties daily, 90 days in advance. So properties are now able to implement those for this. In anticipation of this, our revenue management business partners actually put an annual goal in revenue managers that we're going to track track the variance of your pricing that you actually have on the shelf compared to the pricing recommendations, which has encouraged the user adoption and system adoption to say, either be within variance of what the recommendations are, or be prepared to explain why you know the pricing and the strategy that you should implement, and you're smarter than the system of what the recommendations are providing. So that's really helped, that's really driven some growth as well. An actual quote from from the property that has the largest, most complex pricing strategy. He's actually up to 1,800 rate programs that when he pushes his button now, that gets processed. One push of a button processes 1,800 of these. He processes in less than a minute. He sent a response just basically saying publishing has been pretty spectacular recently. And this is feedback from one of the most vocal critics of the system and the performance of the system. He's just carte blanche just said publishing performance has been spectacular. We had our response time goal to meet within 60 seconds. Our average publishing response time now is 13 seconds. We process 99% of all of our publishes within 22 seconds now. Only 1% of publishes can exceed that 22-second threshold. In terms of growth of the publishing volumes, since November, when we were doing our performance testing of the system, our publishing volume was 650,000 rate programs a day. We've seen a threefold increase, 300% increase, that we're now processing 1.7 million per day, driven by two things. One, that annual goal where our properties are being tracked on how close their pricing on the shelf is to their pricing recommendations has driven a significant amount of growth. Second, publishing is just faster. There's a user satisfaction. This is a difficult thing to get someone to put into tangible numbers. But if you know when you publish, if it's going to be there in 13 seconds, that by the time you left the web application and went to the green screen application to verify if it's been processed or update, it's there. Our users are more willing to go through and make changes to their pricing and respond to the changes within the market. So that's very good from a business standpoint of the way that we've been able to improve the system to be able to address the tactical problem that we had from a publishing performance standpoint, but it also positions us for some of the strategic things that we were away as well. On a more pure technical side, we saw a 50% reduction in our infrastructure costs. With our rules-based solution before, on our 3 servers that we're deployed on, our CPU utilization, these are 32-way servers, so 32 cores per server, 3 times, a total of 96 cores available in the environment. On our rules-based solution, we were running at 80% CPU utilization. With this solution of Neo, it's at 6% now. So we're going to be able to reduce the server capacity and the server footprint and be able to make that much smaller and much more economical. We can actually run, a laptop doesn't have the data to be able to store the full property set. We can run production volume, not just production volume, multiples of production volume on a single 4-core laptop. It's truly mind-blowing. So from the talk I've given today, some of the key takeaways or some of the key themes I wanted to impress upon you. One, utilize the Neo support teams. We found them very responsive and knowledgeable. Dave, I think I see Dave over there. He's come on site multiple times and helped us. Through the course of the project, we did find some defects or things requiring support or some investigation or analysis, things that you would normally find through the execution of a project. Found it to be very responsive and very supportive to be able to help us succeed in this endeavor. Second key thing is this use case is not out there as one of the 6 common use cases. It's not something that's traditionally thought of as what you would necessarily use a graph for. If you have data that's related, take what Emil says to heart. Graphs are everywhere. If you find that your data is related, you may be able to find a use case where graphs can come into play and help you. We took a step back and thought about the problem differently. How can we solve this? This isn't the solution that would have been in any textbook or way of how you do this. We really did some research and thought of what is a creative and innovative way that we can solve this problem that we had. Third, I think we really drove value of having the prototyping up front to drive what are some of the key architectural questions. Things like, are we going to use Cypher? Are we going to use the HTTP interface? Are we going to use embedded mode, server mode? We were able to rapidly go through and make some of those decisions through prototypes. We collaborated with the NEO team, feeding the performance results we were seeing from the different scenarios we have, and really felt like we were able to jointly go through the process to make those questions and decisions on what we were going to do. So one thing I'm also asked is, what are the next things that we're going to do within pricing? First thing is, unfortunately, we're in a version lock scenario. Remember how I talked about Marriott was very conservative and things need to be in place for a long period of time? We still have some elements of that within the culture. Unfortunately, we're in a position that our underlying, the servers where we run HPP are underlying still running Red Hat version 5. So that's many years old. I think 7 is the current version. It might even be 8 at this point. Red Hat version 5 does not allow an in-place upgrade to Red Hat version 6. You have to build out a new infrastructure. Also, Red Hat version 5 will not support Java 8. So in order to go to Neo 3.0, which requires Java 8, we have to do something about a Red Hat problem that we're version locked. Rather than building out a new environment, we're starting some conversations with the NEO team around how do we explore some of the containerization and think about, do we put this out into a cloud environment so that we can look at, we know we still have some periods of time where publishing volumes are heavier than other times, particularly when our recommendations are coming through and we're processing the recommendation updates for the property on a daily basis. Is there something that we can do to look at elastic scaling, and is a cloud solution going to be something that can help us in there? So we're in some very preliminary conversations to be able to say, how do we think about containerizing the solution and positioning us to be able to go to Java 8 and Neo 3. When we get to Neo 3, one of the things that we'll take a look at again, revisit, is with the new callable feature or the stored procedure features within Cypher. Is that something that we could start to take advantage of to be able to scale the units of applications differently and independently? Lastly, one of the things that we have is currently we're putting all of our pricing data from our RDBMS into Neo. So we have fairly heavyweight nodes, probably higher than what Neo would recommend at this point. I think some of our nodes can exceed 1 megabyte in terms of raw data contained within. We have it working, it's performing, but we're going to explore, could we achieve better scalability and performance by looking at a polyglot solution where we use the graph to hold the relationships between the data and then have the actual data in a separate database, probably in a Couchbase or another type of solution like that, to be able to hold the property-related data instead of having that within the nodes. So we're going to look at that as well. Talked a lot about the tactical things here, and I've also talked about, if you remember, that Marriott currently sells by rates. We have some new innovations and new things coming up that Marriott's going to deploy over the next 18 months or so that is going to really be differentiating in some strategic capabilities. This tactical project that started as one isolated use case is really starting to set the stage for how do we be a platform to enable real-time pricing capabilities so that the pricings are calculated dynamically when we take some of that information off of the mainframe. It's going to offer us the ability to start to sell by room and then have a portfolio of rates associated with the rooms. A lot of things from a strategic perspective are coming through.